hydrocarbons. The International Union of Pure and Applied Chemistry serves to advance the worldwide aspects of the chemistry sciences and to contribute the application of chemistry in the service of humankind. In order to name organic compounds, you must first memorize a few basic names. These names are listed within the discussion of naming alkenes. In general, the base parts of the name reflects the number of carbons in what you have assigned to be parent chain. Naming hydrocarbons. The International Union of Pure and Applied Chemistry serves to advance the worldwide aspects of the chemical science and to contribute to the application of chemistry in the service of humankind. In order to name organic compounds, you must first memorize a few basic names. These names are listed within the discussion of naming alkenes. In general, the base part of the name reflects the number of carbons in what have assigned to be the parent chain. The suffix of the names reflects the types of function group present on within the parent chain. Other groups which are attached to the parent chain are called substituents.
A hydrocarbon is an organic compound made of nothing more than carbons and hydrogens. It is possible for double or triple bonds to form between carbon atoms and even for structures, such as rings, to form. There are three main classifications of hydrocarbons based on their types of bonds. If the hydrocarbon has only single bonds, it is called an alkane. If the hydrocarbon has at least one double bond, it is called an alkene. If it has at least one triple bond, it is called an alkyne. And finally, if the hydrocarbon has a benzene ring, it is called an aromatic hydrocarbon.
Structures using UPAC rules. Well, first we have a structure with only single bonds. That means that is an alkane. We count the carb, which is the main chain. There is the one that has more carbons. In this case, is this. We count the carbons: 1, 2, 3, 4, 5. 5 carbon. And we write then chain. The ending is for the single bonds. But there are these. We represent it by counting 1, 2, and is only one carbon. That means that is methyl. And this is how we name this structure. In this structure we have again only single bonds, which is the main chain. There is an only chain, and we count the carbons: 1, 2, 3, 4, 5. There is and that's it.
El foco. Sí, pero lo estuviste moviendo mucho. A ver, revisa ese video.
Pues sí, lo moví mucho porque el reflejo del foco no me dejaba ver
Pero
eso.
sí se ve.
Structure we have a triple bond, and that means that is has a has ending of has descending, which is the main chain. There is this. That means that is an only chain, and it has 1, 2, 3, 4 carbons. Is 14. And has the triple bond in the first carbon. And that's the name of our structure. Structure has double bonds. That means there is an alkene. We choose the main chain. There is this, and count the carbons. 1, 2, 3, 4, 5. Changing is for the double bonds. But we have this. Oh, we need to specify where are the double bonds. There are in the first place. There is 1 and 1, 2, 3, 3 place. And now we have this. There is a methyl and is in the 1, 2, 3, 4 carbon. 4 methyl. And this is the name of our structure. The structure will have a double bond, and that means that it has the ending ene, and which is the main chain. That is this. We count the carbons 1, 2, 3, 4. That means that is 14. And for this, we have two different structures. That is methyl, but we add this. In this structure, we have for this structure, we have an aromatic structure, and well, we have this. Both are methyl, and this chain of 2 that is ethyl. Well, we start for alphabetic order. First is the E, one ethyl, one, two, three, and four, five, and there we have two methyl, and that means that we have a dimethyl. And the name of the aromatic benzene. That is the name. And now we learn how to name the structures of aromatics. The aromatics can be represented by this form or this. We have this. And the aromatics name are benzene. Now we have, well, we have these letters that means where the other chains or carbons are in the figure. We have these chains in the first and 2, 3 in the fourth space. That means that begins with P. P, this is a chain of 2, is ethyl, and this is propyl. We start from alphabet order and begins with E, P, ethyl, propyl, and the name of the aromatic benzene. This is the name. Now we will name this structure. It has only single bonds and is an alkyne. The main chain is this that has a form of a circle on a ring, and for this form then their name is cyclohexane. Cyclo for the form, X for the 6th carbon, and ane because it's an alkyne. Well, now we have these two. That is ethyl, and this is methyl. We start for alphabetical order, and this is the E. And we write 1 ethyl, and then we count 1, 2, 3, 4, 4 methyl. And this is the name of our structure or structure.
Now we will show you a simple table of the main structures for the functional groups related to the hydrocarbons. As you can see, we have the group formula, the class name, the specific example, the common name, and the IUPAC name. These are just a few examples.